Picture what's happening beneath your skin at this very moment. Layered under the surface of your body and wrapped around your organs sit tens of billions of microscopic storage compartments. We call them adipocytes, or fat cells, and they are anything but passive. They listen, they respond. Every minute of every day, they are reading the chemical messages your body sends and adjusting their behavior accordingly. Here's what almost no one tells you. The second you stand up and start walking, a cascade of molecular events begins inside these cells that most doctors will never mention in a routine appointment. Within minutes, not weeks, not months, your fat cells start changing what they do in ways that would look almost surreal under a microscope. Most people imagine fat as dead weight, an inert lump that simply shrinks when you eat less. That picture is wrong. Your fat tissue behaves more like a vast network of secured warehouses, each one fitted with locks, loading docks, delivery routes, and a direct line of communication to your brain. So when you walk for 30 minutes, you aren't just moving your legs. You're transmitting a signal that reaches every one of those billions of cells. Stay with me, because what unfolds next is rarely explained properly. Before we walk through the timeline, let's get clear on what a fat cell actually is, because this changes everything. Your body holds somewhere in the range of 30 to 40 billion fat cells. They aren't simple containers. They're metabolically active endocrine organs, meaning they manufacture hormones and converse constantly with the rest of you. Each one works like a tightly locked vault. Inside sits stored fuel in the form of triglycerides, molecules built from 3 fatty acid chains bound to a glycerol backbone. These can't simply float out of the cell whenever they please. To release that energy, your body has to dismantle them through a process called lipolysis, literally the splitting of fat. And this is not a random event. It demands the right signals, the right enzymes, and the right internal conditions. Here's the part that reframes the whole conversation. Your fat cells were never your enemy. They've been protecting you. When you take in more energy than you need, they expand and lock that surplus away as triglycerides, keeping those fats out of your bloodstream where they could damage your liver, heart, and arteries. It's a safety system. The trouble starts only when these cells are stuffed past their healthy limit. Stretched and overfilled, they begin releasing distress signals, inflammatory molecules that drive insulin resistance, cardiovascular strain, and the slow creep of metabolic dysfunction. Now imagine you walk for 30 minutes every single day. What shifts isn't only the number on the scale. It's the behavior of those billions of cells. They grow more responsive, more efficient, more willing to surrender what they've been holding. They move from a state of constant hoarding toward a flexible balance, storing when it makes sense and releasing when called upon. The research backs this up. Work published on walking interventions has repeatedly shown improvements in blood lipid profiles and reductions in visceral fat over a matter of weeks, and reviews in physiology journals describe how even one bout of moderate exercise increases blood flow through fat tissue and pushes fatty acids out toward working muscle in real time. This has been happening inside you all along. Once you understand the sequence minute by minute, you stop seeing your body as broken and start seeing it as remarkably intelligent. And walking is the language it understands best. So let's trace exactly what happens inside your fat cells once you lace up and head out for half an hour. This isn't magic. It's biology moving through clear, ordered phases. Stage 1, the first 5 minutes, the wake-up call. The instant you start walking, your body does not reach for its fat reserves. For the opening few minutes, it leans mostly on glucose, the sugar already circulating in your blood and stored as glycogen in your muscles and liver. But underneath, something important is switching on. Your sympathetic nervous system fires up, your heart rate climbs, circulation quickens, and your adrenal glands release adrenaline and noradrenaline. We tend to think of these as stress chemicals, but in this context, they're doing useful work. They travel through your bloodstream and dock onto receptors studded across the surface of your fat cells. When adrenaline binds to those beta-adrenergic receptors, it's like turning a key. Inside the cell, an enzyme called protein kinase A switches on, which in turn activates the lipase machinery, including hormone-sensitive lipase and adipose triglyceride lipase. These are the gatekeepers that begin prying apart the stored triglycerides into free fatty acids and glycerol, fragments small enough to slip into the blood. But this takes a moment to build. In these first 5 minutes, your cells have received the order, yet they haven't fully opened the doors. Think of it like a cold engine that needs a little time before it runs smoothly. Meanwhile, your muscles are quietly drawing glucose from your blood, and your insulin level begins to dip. That falling insulin is itself another message to your fat cells, a green light that says it's safe to let go. Stage 2, minutes 5 to 15, the release begins. By around the 10-minute mark, something genuinely impressive is underway. Lipolysis is now running in earnest. Triglycerides are being broken down, and free fatty acids are crossing the cell membrane into your bloodstream. This is where the warehouse picture really fits. Each fat cell is like a storage unit with a normally bolted door. Walking not only unlocks it, it widens the delivery routes by increasing blood flow to your fat tissue. Those liberated fatty acids need transport, and your bloodstream is the courier. Research consistently shows that moderate movement raises blood flow through adipose tissue, helping fatty acids leave the cells and travel toward muscle. Your muscles, for their part, are shifting their fuel preference. Early on, they ran mostly on glucose. Now, as fatty acids arrive, muscle cells pull them in and feed them into their mitochondria, the tiny power plants inside each cell. There, through a process called beta oxidation, those fatty acids are converted into ATP, the energy currency your body actually spends. You reach a kind of metabolic harmony. Glucose burning continues, but fat burning rises alongside it, and your enzyme AMP, a master energy sensor, ramps up to keep the fuel flowing. Your body is learning it doesn't need to clutch everything tightly, because movement is steady and energy keeps arriving. And here's the catch the research keeps pointing to. This is precisely where most people quit. They walk 10 minutes, feel fine, and stop, missing the deeper shift that's only just beginning. Stage 3, minutes 15 to 30, peak fat burning and cellular change. Welcome to the sweet spot. By 15 to 20 minutes in, your body has settled firmly into fat burning mode. Studies on fat oxidation point to a zone, often called fat max, that sits at a moderate intensity, roughly the pace of a brisk walk where you can still hold a conversation but feel slightly winded. In that window, a substantial share of the energy you're spending comes directly from fat. Your cells keep releasing fatty acids, your muscles keep consuming them, and something easy to overlook is happening in the background. Your fat cells are becoming more receptive to future signals. Every walk trains them to respond more readily, building up the quantity and effectiveness of the enzymes that drive lipolysis, improving blood flow to the tissue, and nudging the very genes inside those cells toward a more adaptable, metabolically active state. Research on aerobic training describes increases in the proteins that ferry and oxidize fat, including the fatty acid transporter CD36, the machinery that makes fat burning efficient in the first place. There's also an intriguing player worth mentioning. During sustained exercise, your muscles release a signaling molecule called irisin, first described by Bruce Spiegelman's lab in 2012. Irisin appears to encourage ordinary white fat to take on some characteristics of brown fat, the energy-spending tissue that generates heat, a shift researchers call browning. The strongest evidence here comes from animal work, and its full importance in humans is still being mapped. So it's best understood as a promising piece of the picture rather than the whole story. By the time you reach 30 minutes, your glycerol levels are up, your insulin is low, and your body is in a state of active fuel turnover. You're not just spending calories. You're gradually retuning how your metabolism operates. Stage 4, after the walk, the lingering effect, and long-term adaptation. The benefits don't switch off the moment you stop. For a stretch of time afterward, your body keeps burning fuel at a slightly raised rate, an effect known technically as excess post-exercise oxygen consumption, or EPOC. With moderate walking, this afterburn is real but modest, so don't expect dramatic numbers from a single stroll. Your muscles are restocking glycogen, your fat cells continue feeding fatty acids into that recovery, and your mitochondria stay busy. The genuine transformation, though, comes from repetition. Commit to a daily 30-minute walk, and your fat cells undergo lasting change. Their reluctance to release stored fat eases. They lean toward letting go rather than locking down. Inflammatory markers settle, and insulin sensitivity measurably improves. Your physiology starts treating movement as its baseline rather than a rare interruption. And here's the satisfying irony. The more you walk, the smaller your fat cells tend to become, not because they vanish, but because they release what they held. Smaller, healthier fat cells behave better, producing protective hormones like adiponectin, which helps guard against insulin resistance and chronic inflammation. Let me ground all of this in actual science, because none of it is wishful thinking. Reviews of how aerobic exercise shapes fat metabolism point to several rate-limiting steps that determine how fast fat is burned during movement, the breakdown of triglycerides inside fat cells, the transport of fatty acids through the blood to muscle, the use of fat stored within muscle itself, and the entry of fatty acids into mitochondria. Moderate intensity walking happens to support all of these at once. Other work in exercise physiology has shown that during moderate effort, fat can supply a sizable fraction of total energy expenditure, more than many earlier estimates assumed. Push the intensity very high, though, and the body swings back toward burning glucose. Sprinting and hard running shift the fuel mix away from fat, while walking keeps you parked comfortably inside the fat-burning range. Older thinking assumed only total duration mattered, that you'd need hours on your feet to see results. Newer data suggests consistency does more heavy lifting than sheer length, with regular sessions of 30 to 40 minutes linked to reductions in visceral fat, better HDL cholesterol, and lower inflammation, even without strict dieting. A quick word on safety. Walking is about as low risk as exercise gets, but a few people should check with a doctor first, including those with serious joint problems, uncontrolled heart conditions, or recent surgery. If you have diabetes, walking can lower blood sugar significantly, so monitor it closely, especially if you take medication. For nearly everyone else, a daily 30-minute walk is one of the most evidence-backed things you can do for your metabolic health. Listen to your body, start where you are, and build gradually. So let's return to the question we opened with. What happens inside your fat cells when you walk for 30 minutes a day? They wake up, they respond, they release, they adapt. Over time, they become more flexible, more efficient, and more willing to work with your body instead of against it. You aren't at war with your own physiology, and your fat cells were never the villains. They've been doing their job, storing energy and protecting your organs. By adding consistent movement, you simply hand them a new instruction. It's safe to let go now. We're moving. There's no need to hoard. And in time, your body listens. So tell me, what surprised you most? The biology itself, the fact that 30 minutes is enough, or the idea that your fat cells have been protecting you this whole time? Drop your thoughts in the comments, because your experience might be exactly the nudge someone else needs. And if you want more explanations grounded in real science without the hype, subscribe and stick around. In the next video, we'll unpack the myths around fasting and fat loss, and why getting this wrong can quietly cancel out all your hard work. Now, go take that walk.